Hello, welcome back to an advanced analysis of single subject design. This is video part 8. Now in the prior video part I listed for you 3 types of multiple baseline designs across settings, across behaviors, and across participants. Now within each of those types of multiple baseline designs there are variations. So variations of the multiple baseline design include moving treatment multiple baseline, cumulative treatment multiple baseline, multiple probe design, and non-concurrent or delayed multiple baseline design. So in other words, you can have a multiple baseline design across settings that is a moving treatment or a cumulative treatment, or multiple probe design or non-concurrent or delayed multiple baseline design. Similarly, you can have a multiple baseline design across participants, that is a moving treatment design or cumulative treatment or multiple probe design and so forth. The moving treatment multiple baseline design, the intervention is applied for one baseline and then removed before being introduced on the next baseline and so on. Increased confidence in the intervention's effects is generated by conducting follow-up sessions with the intervention in place. In the cumulative treatment multiple baseline design, which is the type that you have seen so far, is the intervention remains in place as you stagger the introduction of the intervention across subsequent baselines. Increased confidence in the functional relation is provided by an extended stable data path in each panel of the multiple baseline design. So here's an example of each from Bailey and Birch 2018. And in the moving treatment design, notice there are 3 panels or 3 baselines. In the first baseline, independent variable is introduced, but then it's terminated, and later on they collect data in maintenance probes. The independent variable is terminated before the independent variable is introduced in the second baseline, and then that independent variable is terminated before introducing the independent variable in the third baseline. In each baseline, maintenance probes are conducted. That is, data are collected after some time has passed since the intervention was terminated. In the cumulative treatment multiple baseline design, the independent variable is introduced in the first baseline, and it continues to be implemented in sessions as you gradually stagger the introduction of the independent variable to the subsequent baselines. So notice that there's a phase change line that separates the independent variable condition from maintenance probes in the moving treatment multiple baseline. But in the cumulative treatment multiple baseline, there's just a phase change line that separates baseline from the independent variable. So that's a visual feature that distinguishes between the designs that will help you to determine which type of design you're looking at when you're looking at examples, if it's moving treatment or cumulative treatment multiple baseline design. ASR 23. In which design is the treatment in one baseline discontinued before the treatment in the next baseline is introduced? Is it A, moving treatment multiple baseline, or B, cumulative treatment multiple baseline? A couple more seconds. Alright, I'll close the poll, and the answer is A, moving treatment multiple baseline. Now let's look at the multiple probe design. You can save time and resources with a multiple baseline design by conducting a multiple probe design, as suggested by Horner and Baer in 1978. Now, a multiple probe design does not require continuous measurement, meaning you can continue to run sessions with the independent variable in place, but you're not collecting data every session. It's particularly useful when the skill is not in the learner's repertoire, so it is obvious that the data will be 0. Okay, that's specifically pertaining to baseline, right? If the skill is not in the learner's repertoire, it doesn't even, in most cases, make sense to keep running sessions where you're collecting data on the behavior and just recording 0. Right? So instead of collecting data every session, you just collect probe data. So periodically you collect data during a session to verify that the skill is still absent from the learner's repertoire. You can just collect data at strategic time points that allow for visual analysis and demonstrations of functional relations. This graph from Sheps et al. In 1998 shows an example of a multiple probe design. On the x-axis are observations, and the y-axis is the number of child communicative interactions per minute. And you can see there are 4 panels here. We'll just look at the top 2 panels to illustrate this example. There are 2 participants, there's Ben and Corey, and the dependent variable is the experimenters were measuring communicative interactions per minute for each of these individuals during a snack time. Okay, and you can see that they collected data on the dependent variable for both participants during baseline, and the sessions for which there isn't a data point is a session where they did collect this, even though when there's data point is missing, they ran a session, a baseline session, but they just didn't collect the data. Okay, so the naturalistic teaching intervention plus VOCA, it's okay that if you don't know what that is. It was introduced first on Ben's baseline. You can see an increase in the dependent variable. It was not introduced to Corey until this session 24. So in order to demonstrate experimental control over the dependent variable by the intervention, they had to collect at least 1 more data point during baseline for Corey, while the intervention was in effect for Ben, just before introducing the intervention for Corey. Right? So then when they introduced the intervention for Corey, they also saw an increase in the dependent variable, thereby demonstrating experimental control over the dependent variable by the intervention. And they didn't have to collect data every session. And even when the independent variable or the intervention was implemented, they only collected data during some sessions. Right? But I should note that the independent variable was present in all of the sessions in those phases. Next is the delayed or non-concurrent multiple baseline design. Now historically, the multiple baseline design was one of 2 primary designs used in ABA. The multiple baseline design requires data on multiple baselines to be collected simultaneously. Alternatively, Watson and Workman in 1981 proposed an alternative multiple baseline design called a non-concurrent multiple baseline design, in which the onset of data collection could be staggered across baselines, in which the onset of data collection could be staggered across baselines in case simultaneous data collection was not possible. In other words, you complete an A-B evaluation for one student, then later repeat the A-B evaluation for another student, but you collect more baseline data for student 2 and each subsequent student, so that when you stack the graphs, like so, it looks like a typical multiple baseline design. Okay. Now, when it's across participants or across students, like I was describing here, the graphs would look like this. Okay. Now, if you use a delayed or non-concurrent multiple baseline design across behaviors, it would look like this, where this across behaviors in a single participant or learner or student, you're collecting data on baseline for one behavior but not for the second behavior. Then you introduce the independent variable, and when you introduce and then you discontinue data collection, right? But data collection for baseline for behavior 2 then begins. Okay, so let me say that again. So you collect data in baseline for behavior 1, and then you collect data on the behavior during the intervention for that behavior 1, and then you stop collecting data on behavior 1 and you start collecting baseline data on behavior 2. All right, the way these are arranged, though, it looks as if these data were collected at the same time as these data, but that's not the case. This was a delayed or non-concurrent multiple baseline. These data were collected first, and then the data in the second panel were collected. Notice that there's 1, 2, 3, 4, 5 data points in baseline for behavior 1, and there's 1, 2, 3, 4, 5, 6, 7, 8 data points collected in baseline for behavior 2. That's critical for a demonstration of experimental control in the delayed or non-concurrent multiple baseline design. You have to collect more data across more sessions in baseline for each subsequent baseline, showing that so that you can demonstrate that when the independent variable is introduced, it doesn't matter how long the person was in baseline, the behavior it doesn't matter how long the behavior was in baseline, it only changes when the independent variable is introduced. Okay, so let me clarify that a little bit more. With behavior 1, it appears that the behavior didn't increase until the session 8, right? So what happened for behavior 2 is data were collected for at least 8 sessions, right? So 1, 2, 3, 4, 5, 6, 7, 8 sessions with no change in the behavior. And then they introduced the independent variable, and there's a change in the behavior. Okay, so that's a demonstration of experimental control, because behavior is only changing when the independent variable is introduced. Now, the uses of the delayed or non-concurrent multiple baseline design is when a reversal design is not feasible or acceptable, you can use this type of design. Or when concurrent baseline data collection is not prudent or possible. In other words, you have to wait to collect data on the second, third, or fourth baseline. And then when a second or third participant or client or student in the classroom is not available for data collection. In other words, this is a really nice design to use to experimentally evaluate the effects of interventions or teaching practices in the classroom when you cannot intervene on more than one student at a time, or you have a student that has a need for an intervention that other students don't have a need for. Or for a given student who has a need for an intervention, you only have the resources to collect data on one, but not multiple of their behaviors, and so forth. So this is a very useful and practical design, but its limitations are that delayed baselines may be shorter than typical baselines, thereby weakening demonstrations of experimental control. And when across behaviors, the design may mask changes in untreated behaviors that occurred when the treatment was introduced on an early baseline. Okay, now you can combine non-concurrent multiple baseline designs and non-concurrent multiple probe designs. So for example, in this study here, they have 2 participants, right, Lynn and Ian. And this is a non-concurrent multiple baseline design in that the data for Ian were not collected at the same time as the data for Lynn. But also for both participants, data were not collected every session. Instead, data were collected strategically at specific time points across baseline sessions and intervention sessions. ASR 24. In which design do you continue to run sessions but do not collect data every time the intervention is implemented? Is it A, moving treatment multiple baseline, B, cumulative treatment multiple baseline, C, multiple probe design, D, delayed or non-concurrent multiple baseline, or E, non-concurrent multiple probe design? A couple more seconds. Okay, I'll close the poll and the answer is C, multiple probe design. ASR 25. With which design can you evaluate the treatment in one learner at a time, but data are collected every session? A, moving treatment multiple baseline, B, cumulative treatment multiple baseline, C, multiple probe design, D, delayed or non-concurrent multiple baseline, or E, non-concurrent multiple probe design. A couple more seconds. Alright, I'll close the poll, and the answer is D, delayed or non-concurrent multiple baseline. ASR 26. With which design can you evaluate the treatment in one learner at a time, and you don't need to collect data every session? A, moving treatment multiple baseline. B, cumulative treatment multiple baseline. C, multiple probe design. D, delayed or non-concurrent multiple baseline. E, non-concurrent multiple probe design. A couple more seconds. Okay, I'll close the poll. The answer is E, non-concurrent multiple probe design. So that's a combination of a non-concurrent multiple baseline design with a multiple probe design. You can evaluate the treatment of one learner at a time, and you don't need to collect data every session. That wraps up this video part. I'll see you in the next video part with an advanced analysis of the changing criterion design.